Hello everybody and welcome back to another video. This is going to be the last SAT math video that we post in a while, except on shorts. So really let's just get into it, and part of it's going to be functions like we did last video, except they're not. It's going to be a different types of functions, different types of questions. And then the first part is going to be some circle geometry today. So circles, okay. Practice problem 1 of 2. A circle on the xy plane has this equation. Which point does not lie on the interior of the circle? Well, basically, if you're doing this with algebra, you would find the center, you'd find the radius, which is 5 in this case, and then you'd have to find the distance between the center and any one of these points. But we're going to use Desmos because, like I say, and everyone says, Desmos is your best friend, okay? I know there's very few people who think that it's bad. So let's put our points here. And then let's see, our center is -3, 1, because remember, -h, -k, and the center is h, k, so -3 and 1, and then this is r squared, so r equals 5. Okay, so with this knowledge, let us go to Desmos. So let's make the circle. We just put in the same equation. Plus y minus 1 squared equals 25. Circle. And then really all we have to do is plot these points. So that's in the circle, so the answer is not going to be A. That's in the circle, so the answer is not going to be B. That's in the circle, so the answer is not going to be C. So what is the answer going to be? Well, we can assume that it's D, and it is D, so it's outside of the circle. So that's basically an easy way to do that, right? If you don't want to take the distance formula and all that, D's our answer. Now, okay, and the xy plane is circle C has center C with coordinates h, k. Points A and B lie on the circle. Point A has coordinates point A has coordinates h plus 1, k plus square root of 102, and angle ACB is a right angle. What is the length of AB? So what I want to do is draw out a circle here. And let's say that our center is 0, 0, just for this example. And then we obviously say that this is 0, 0. Now, let's say we have point A here and point B here. So this is C, this is B. So this is something like 90 degrees, right? Because right angle. And so then it wants us to find like this here. Now, what I want to do is find the radius. How do I find the radius? Well, we take the distance from the center to one of the points, and it gives us point A. So using 0 as our example, let's just take the distance. Well, the distance is going to be the square root of x1, which is our h plus 1, or x2, which is our h plus 1, minus x1, which is our h, which would just be 1, squared plus k plus the square root of 102 minus k, which is just the square root of 102. And the reason I use 0 as the example is because then you don't have to deal with like the h, k, whatever. Like you could literally just plug it in like this. So what does this get with? Well, this leaves us with our radius, because remember, the distance equals the radius, is a square root of 1 plus 103, or 102, sorry. So it is a square root of 103. Now, this is the hypotenuse of this triangle here. And you know it's the hypotenuse because it's directly across from the right angle, making it the hypotenuse. That's just how that sort of works. So, what I want to do then is use this as A and B. Well, these are like side CA and CB to find the hypotenuse. Well, h is going to be the square root of one side squared. So square root of 103 squared is 103, plus the other side squared, which is 103. And so this is going to be the square root of 206. And that's our h, which is also AB. So our answer is going to be A here. Now moving on to the next topic, we have nonlinear equations in one variable and systems of equations in two variables. Which ordered pairs a solution to the system of equations above? Now, where do you suggest we do this? Well, Desmos. No need to do any writing if you can just use Desmos. So let's just write this here. Equals 1, x minus y equals 1. X plus y equals x squared minus 3. Let's plug these in Desmos and find some solutions. So x minus y equals 1. X plus y equals x squared minus 3. Solutions. I don't think any of the answers here are negative. They are not, so it's going to be this one. Now, we really just have to find out what this answer is, right? So let's see. Square root of, let's try the first one. Square root of 1, or square root of 3 plus 1. Oh, that looks to be our x coordinate. Is there another one here? No. So I'm going to bet that A is our answer. And it is, because if we just do the square root of 3, that would be our y coordinate here. So answer is A, right? You don't have to do any hard work. Just use your calculator. Pretty simple. Okay, last question, guys. During a 5-second time interval, the average acceleration in meters per second squared of an object with an initial velocity of 12 meters per second is defined by the equation A equals VF minus 12 over 5, where VF is the final velocity of object in meters per second. If the equation is rewritten in the form VF equals XA plus Y, where X and Y are constants, what is the value of X? Well, we have A equals VF minus 12 over 5, and we're trying to isolate VF. So what I'm thinking is we multiply both sides by 5, just to get rid of that denominator. So we have 5i equals VF minus 12, or 5a, sorry. And then x is attached to the a, so we can already assume that the answer is 5. And that is going to be the answer, so you'd be correct. But just to get it in this form, let's just add 12 to both sides, right? Why not? So 5a plus 12 equals VF. So given this, you see that x is attached to the a and it's still 5, right? Adding the 12 didn't change anything. So the answer is still going to be 5, and that is the last question of the SAT Math series, at least for a while. Like I said, unless on short. So thank you guys for watching, and have a good day.